Hello and welcome to another explanation video. Today we talk about a 4-stroke combustion engine. There are a lot of combustion engines around in this world, but we talk about the most common one, the 4-stroke combustion engine. Quick agenda overview. I will show the structure of a 4-stroke petrol or gasoline or otto engine, call it what you want, and the most important parts of the engine. Then I explain the 4-stroke principle, again based on the petrol engine, and explain every single stroke step by step. And in the last step, I state the main differences between a 4-stroke petrol engine and a 4-stroke diesel engine, and present you some PV diagrams. So let's begin with the general structure of a petrol engine. Here you can see a cross section of one of these engines. First of all, we have the whole engine housing, and this housing consists of the crankcase, in which the crankshaft, connecting rod and counterweight are spinning around. Then next we have the cylinder, in which the piston moves up and down, and then the piston, and then at next the cylinder head with the intake and the exhaust, in which the camshafts with the cams that control the valves to open and close, and last but not least we have the spark plug that ignites the fuel air mixture at the exact right time when we need it. So yeah, now we know the general structure of a petrol engine, and at next we have the explanation of the 4 strokes. So yeah, the 4 strokes are named by the action that happens during these strokes. So let's begin with stroke number 1. Stroke number 1 is the intake. In this phase, the piston moves from its upper dead center, the highest point, to its lowest point, the bottom dead center. During this movement, the intake valve opens and lets the fuel air mixture that was mixed shortly before in the carburetor flow into the cylinder. The movement of the piston causes the crankshaft to rotate half a revolution, and the exhaust valve, that's the left valve, remains closed. And the overall pressure roughly equals the air pressure, the surrounding air pressure, with tendency to a slight negative pressure. At stroke number 2 we have the compression, and yeah, the name says it all, it does what it says. So first of all we have the intake valve that is closing, so no, both valves are closed. The piston now moves up from its bottom dead center, and while doing that it compresses the fuel air mixture because it has nowhere to escape now. Due to the compressing of the mixture, the temperature and most important, the pressure rise. And just before the piston reaches its upper dead center, the spark plug ignites the mixture, which leads to an explosive increase of the temperature and pressure. And when the piston reached its highest point, the upper dead center, the crankshaft now rotated 1 revolution since the beginning of stroke 1. Moving to stroke number 3, the combustion. The piston is at its upper dead center and is pushed down towards its lowest point due to the combustion and expansion of the mixture. And during the movement of the piston down to its bottom dead center, the mixture cools down while it is expanding. This stroke is the only one where work really is performed, and all other strokes are just consumers. And then at last we have stroke number 4, the exhaust. The burned fuel air mixture now must be thrown out of the cylinder, and to do so the exhaust valve opens when the piston reached its bottom dead center, and then it moves up again and pushes the used fuel air mixture out through the exhaust out of the cylinder. And with the end of the stroke reached, the crankshaft rotated 2 revolutions since the beginning of stroke 1, meaning that one up and down movement of the piston turns the crankshaft 1 revolution, and with all 4 stroke cycles done, it does that 2 times. So we have 4 strokes and 2 crankshaft revolutions. The cycle is now finished and everything starts all over again with stroke number 1. And for visualization purposes, we have an animation of the 4-stroke engine right here. Let's begin. That's the intake, then it compresses the air, combusts, and then everything gets pushed out again out of the cylinder, and it does that all and all over again. So now that we have the general knowledge on how the 4-stroke system works, we can move on to the main differences between a petrol engine and a diesel engine. Diesel engines also use the 4-stroke system, and yeah, now we want to see which differences they bring up. So yeah, let's have a look. So at first, the diesel engine does not have a carburetor. The diesel is injected directly into the cylinder during stroke number 2, the compression stroke, and doesn't really mix up with the air that was let in during the intake stroke. In a petrol engine, the fuel and air are mixed in the carburetor shortly before the mixture enters the cylinder, and the fuel and air form a great mixture. Next on, we have the spark plug and self-ignition difference. So yeah, let's have a look on how each type burns its fuel-air mixture. So in a petrol engine, the spark plug ignites the fuel-air mixture. Easy thing, easy to understand. And yeah, in the diesel engine, it's a little bit different. There, the diesel ignites itself, and that's due to the high temperatures and pressure that is reached in the diesel cylinder. So let's move on to point number 3, compression. A diesel engine has a lower clearance from the top of the piston to the cylinder head because the risk of self-ignition is lower in a diesel engine than in a pre-mixture petrol engine. And because of that, the compression ratio in a diesel engine is higher than in a petrol engine, which makes it more efficient. Last but not least, we have the Otto versus diesel cycle. In an Otto cycle, the vibrations are low due to a controlled combustion with the spark plug of the fuel-air mixture. And in a diesel engine, in a diesel cycle, the combustion is uncontrollable because the diesel can self-ignite everywhere in the cylinder, causing the engine to vibrate more. Therefore, the diesel engine has to be built more solidly than a petrol engine. And last but not least in this presentation, we have the pressure volume diagrams. So let's have a quick look. So we have the PV diagram of the petrol engine on the left and from the diesel on the right. Yeah, we can clearly see the main differences in these diagrams, because you can see the diesel engine diagram. There we have a lot more pressure than in the petrol engine, and we can see that the highest pressure in the petrol engine is reached only when the piston already works its way down in stroke number 3. And in the diesel engine, the pressure rises extremely after the self-ignition, and the highest pressure point is reached shortly after the piston left the upper dead center. And if we put both diagrams together and on top of each other, we can see that the diesel engine encloses a bigger area than the petrol engine, which, according to the outcome of this diagram, tells us that the pure performance of the diesel engine is higher than the one on the petrol engine. And yeah, that's it. That was a quick overview over the 4-stroke combustion engines. Thank you for listening. If you liked the video, leave a like, leave a comment, and see you next time. Maybe another explanation video.